This is 10.1. We're going to be working on what we call the sum and difference formulas for sine and cosine. So this is a formula you need to know. That's really the hardest part about this, in my opinion, is just knowing the formulas. So the one thing that we want to make sure that we are clear about here is when we are looking at this formula, we have cosine of alpha plus or minus beta. What that means is this formula can be either plus or it can be minus. And based on whether it's plus or minus is what it's going to be over here. So what you should see is that if it's plus in this form, it's going to be minus over here. And if it's minus over here, it's going to be plus here. The sine one is a little bit easier to remember because plus always matches up with plus and the minus always matches up with minus. So what we're going to do is we got to be able to use this in both directions. The first one, it's showing we have the cosine of 105 degrees times the cosine of 15 degrees plus the sine of 105 degrees times the sine of 15 degrees. So what we want to do is identify which one of these sum and difference formulas we're going to be using. Because it's cosine, cosine, sine, sine, we're clearly going to be using the cosine one right here because that's the one that has cosine, cosine, and sine, So what does that mean? Well, basically what we would want to do is identify which angle we're talking about here. So if we're using our angles, this is going to be alpha and this is going to be beta. So our 105 is our alpha and 15 is our beta. So what we're going to do is just take the formula here, and instead of us writing out this whole thing, we're going to write alpha, and then because this is a positive, this is going to have to be a minus over here, because remember the positive will match up with the minus. So it'll just be the cosine of 105 minus 15. So that ends up being the cosine of 90. And the cosine of 90 is just equal to 0. Okay, and that's really all you're doing on ones like this is once you identify which one you're using, plug your angles in, and usually your angles are going to come out to something that you can figure out fairly easily. Okay, the next example is if we're trying to find the exact value of sine of 15. So what we're going to do here is, this is a little bit interesting. All of these sum and difference formulas are dealing with angles that we're not familiar with without, unless we use the calculator. But what we're going to do is we're going to use our sum and difference to create angles that we are comfortable with. So in other words, we know that our main angles are things like 90 and 45 and 60 and 30. So what we want to do is figure out, is there any combination of addition or subtraction problem that we can use to get to 15? Well, in this case, to get to 15, I'm thinking of, instead of 15 degrees, we're going to do the sine. And instead, it's going to be 45 minus 30. Because if I do 45 minus 30, it equals 15. So now I'm actually using a sum and difference formula. So now it becomes the sine of 45 degrees times the cosine of 30 degrees. And because it's minus here, it will be minus over here. And then it's going to be the cosine of 45 times the sine of 30. And we know what all of these are. If we draw our special right triangles, this one can be our 30, 60, 90. So therefore we have 1, we have square root of 3, and we have 2. And then our other triangle, our 45, 45, 90, that's just going to be square root of 2, square root of 2, and 2. So now what we can do is identify each one of these. So going through and identifying these, we have the sine of 45 is going to be the square root of 2 over 2. So it'll be this multiplied by the cosine of 30, which cosine of 30, if we look over here, is going to be the square root of 3 over 2. And then that'll be minus the cosine of 45, which is square root of 2 over 2. And then we have our sine of 30, which is going to be 1 over 2. And then we're just going to multiply these, and we get square root of 2 times square root of 3 is square root of 6 over 2 minus square root of 2 over 2. And then we can just combine those fractions, and we're not going to actually evaluate here. We're just going to leave this as the square root of 6 minus the square root of 2, and that will all be over 2. That's an exact answer. And again, all this is, ooh, a little messed up there, but square root of 6 minus square root of 2 over 2. So all we have here is an exact answer. We are breaking it down using our formula into things that we are familiar with that we can do without a calculator. Okay, so down below here, I want you to try one on your own. Very, very similar. Again, try and find the two angles that you know that you can use. If it's not an angle from a special right triangle or 90 degrees, then it can't work. So you need to make sure that you can combine two angles that you're familiar with. And it can be addition or subtraction. So try that, and we will see how you do. Okay, before we get into this one, we first need to make a correction up here. 2 times 2 on the bottom up here should have been 4. So let's make sure we fix that. So these should have both been 4. And then that would have made the final answer 4. So when you get down here, you should have had cosine. You should have done 60 plus 45 is equal to 105. So we write out our formula using the sum and difference formula. Cosine of 60 is 1/2. Cosine of 45 is square root of 2 over 2. Sine of 60 is square root of 3 over 2. And sine of 45 is square root of 2 over 2. And combining that all together, you should get square root of 2 minus 6 on top and then 4 on the bottom. Okay, so let's continue on here to the next page. Okay, so we're going to get into this a little bit more. So it says, show that the sine of 3 pi over 2 minus x equals negative cosine of x. Well, again, we are using the sum and difference formula here. So what you want to do is imagine that this is our alpha, and then this right here is our beta. So when we write this out as a sum and difference, it's going to look like this. Because it's the sine, it's going to be the sine of 3 pi over 2 times the cosine of x, and then it'll be minus the cosine of 3 pi over 2 times the sine of x. And then what we do is we just evaluate. The sine of 3 pi over 2 is negative 1. And then we just bring the cosine of x down. Minus the cosine of 3 pi over 2 is actually 0. And then we bring this down. And what you should notice is 0 times this is going to cancel that out. And we're just going to be left with negative 1 times cosine of x, which is negative cosine of x. And that's done. Okay, so that's an example of that type of problem. Okay, now moving on. Okay, this one may seem like it's tough to do, but it's actually not that bad. What we need to do is, the first thing is we got to pay attention to the bounds that they're giving us. Okay, so the bounds that they're giving us is basically telling us which quadrant we're going to be in. So what I'm going to do is I'm going to draw our triangles to start. Because what they're telling us is the sine of alpha. Alpha is between 0 and pi halves, which means alpha is going to be in our first quadrant. So that's the first thing that we're going to do. Is this is our alpha right here. Okay? And let's assign our sides. So our sides here, opposite is going to be 4. Hypotenuse is going to be 5. And if we were to figure out what our adjacent is by doing the Pythagorean theorem, we would notice that we get 3. Now, beta is going to be in our second quadrant. So we're going to do a triangle in the second quadrant. And that's our beta. And again, the opposite side here is 5. The hypotenuse is 13. And if we were to do the Pythagorean theorem here, we would find out that our third side is going to be 12. But don't forget, because we're in the second quadrant, that 12 has to be negative. So now what we do is, because we want the cosine of alpha plus beta, we're going to write out exactly what that looks like. So the cosine of alpha plus beta, the sum and difference, is going to look like this. It'll be cosine of alpha times the cosine of beta, and that will be minus the sine of alpha times the sine of beta. And then all we're going to do is use our special right triangle, or not our special right triangles, but our triangles over here to identify. Cosine of alpha is going to be 3 over 5. Cosine of beta is going to be negative 12 over 13. Minus the sine of alpha is 4 over 5. That's actually given to us above. And the sine of beta above is 5 over 13. And then when you just combine these fractions, you get negative 36 over 65 minus 20 over 65, which equals negative 56 over 65. And that's what our value would be. So again, what you're doing is setting up your triangles in the proper quadrant, getting all three sides with the proper positive or negative, and then just writing out your theorem, or not your formula here, and then just assigning the values based on the right triangles. So what I want you to do is try and do this one on your own. Hopefully it shouldn't be too bad, and let's see how you do. When setting this up, you should have gotten another 3, 4, 5 triangle, and then a 24, and then negative 7, 25 triangle. And then here was your formula for the sum formula for a sine. And you should have had 3/5 times negative 7 over 25 plus 4/5 times 24 over 25 to get a grand total of 75 over 125, which reduces down to 3/5. So hopefully you got that. Hopefully this makes sense. And if you have any questions, bring those to class, and I will see you then.